Hi, my name is Shu-Kai Hu. I'm currently a postdoc in Khademhosseini Lab in UCLA, and I'm a chemical engineering from Taiwan. So my research interest is tissue engineering, especially 3D bioprinting. Mm-hmm. So the purpose here is to make some functional tissue, because think about it, when you age, your body becomes weaker and weaker. Mm-hmm. And it's because your part of your tissue or organ, they become dysfunctional. And it would be nice if we can just replace them instead of taking drugs for the rest of your life.
Yeah.
Yes.
Of course.
So to make this functional tissue, we need to mimic the architecture of those tissues, because if you look into our body, the tissues in our body, they actually have their particular architecture. It basically means different cell types comes together and they organize themselves in the particular way, so that we can obtain the specific function. For example, your heart, your cardiac muscle cells, they align into like a parallel fibers, and they partially connect to each other. In the between, there are some endothelial cells and forming the vasculature to provide nutrient and oxygen. And in this architecture, we can get the synchronized beating function. Yeah. So we aim to like mimic this particular architecture as much as possible. So 3D bioprinting is actually one of the most promising method that allows us to fabricate this complex construct. So by definition, you use computer program to apply to your 3D bioprinting methodology to distribute the cells and the extracellular matrix, those hydrogel materials, into the place you want them to be. So you can get the particular architecture you want. Yes. So like one of my project is about developing the oxygen releasing bioink. Bioink means the cells with the hydrogels. And the reason we want to develop this ink is to provide more oxygen for this tissue, because one of the challenging here is when you want to engineer a thick tissue, you usually face some necrosis problem, because cells in the middle, they don't get enough oxygen, so they basically die inside the middle.
Right.
Yeah, because we don't have the capillary network inside here, not like our body. So we want to provide them the long-term sustained oxygen releasing, so they can survive inside and become a mature or functional tissue. It depends on different types of hydrogel and cell or cell density. All those parameters will influence it. But if it's in our body, if it's more than like 1 millimeter, you will get this problem. So that's why we have very high density of the capillary vasculature in our body. In vitro, I can say approximately like 2-3 millimeter is kind of the critical point. You will get the necrosis problem. Yes. Right now we aim for 2 weeks at first. We want to provide like approximately 21%, just similar to the air or the blood in our body, for 2 weeks. And of course, if we can aim for longer, that's also good. But because there's one reaction called angiogenesis in our body, which means your endothelial cell, they want to generate vasculature because they feel, oh, there's no supply of nutrient and oxygen. So it's approximately takes 2-3 weeks. So our aim is like to provide them oxygen to survive for 2-3 weeks, so they can form their capillary network vasculature, so we have a good tissue in the future. Yeah, we use the when we develop this oxygen releasing bioink, we need to measure their releasing kinetics, we use the TBR 1025. It's a radical analyzer or something, and we combine with the oxygen sensor. It allows us to measure the oxygen releasing of our material accurately and day by day, and get the stable result. Yes. Mm-hmm. So yeah, it's actually very convenient compared to other fluorescent-based sensor. You don't need to add the fluorescent indicator in your system. That makes you concerned, right? So it's simple and straightforward. Just put your probe inside your glass vial, then you got the result. I guess one of my dream is to see artificial human born in this world in my life. Because just like those science fiction, it's very interesting, right? You create a life, and there must be lots of ethic problem at that point. And I do enjoy to see the new technology to impact this world. And I believe it will change a lot, because lots of fantasy ideally can be accomplished by artificial human. Yeah. And by that time, it means it's possible you can live forever, right? You can generate a life, you can generate little organ for sure, you can generate little tissue, you can replace everything in your body. Theoretically, you can live forever at that moment. It's super interesting to me.